Hello, everyone. Welcome to the second week of the Women in Security at Elastic Summit. My name is Tanisha Turner, and we're here today with Susan Chang, who will be presenting applied machine learning and cybersecurity. Susan is a principal data scientist here at Elastic, and she has a lot of experience. She is a founder of Quill Game Studios, and she manages 10 long-term contributors there. You can find Susan speaking at conferences such as PyCons, Toronto ML Summit, and many more events. Without further ado, we will turn it over to Susan, and she will start to present. And go ahead, Susan. Thank you.
All right. Thank you very much, Tanisha, for the introduction. I will be sharing my screen. Okay, great. Can you see it?
Yes, we can see it.
Okay, perfect. So yeah, hi everyone. I'm Susan. I'm a principal data scientist here on the security machine learning team at Elastic, as Tanisha's mentioned, and I'm really excited to be here today. I'll be going through applied machine learning in cybersecurity and some of the behind the scenes of how we use it in Elasticsearch. We'll have 3 steps for this talk. I want to start from the top about our goals in cybersecurity, since it'll set the stage of what the goal of machine learning in cybersecurity is. I know that sometimes machine learning can be mysterious, right? Like, what does it actually do under the hood? And that's what I want to share with you in the second portion of this talk, which is to look behind the scenes and understand the data that's required for building ML for cybersecurity. In addition, we'll use real examples of machine learning, or ML, that I'll be abbreviating sometimes in this talk, that users can access today on the Elasticsearch solution, so that the ML concepts aren't just abstract. You'll be able to see how we can use machine learning and hopefully extend this knowledge to other ways that machine learning can help us cut through the noise, automate the boring stuff, and focus on what we're good at. So first, we'll talk about our common goals in security. Here's an example of what a SOC analyst or cybersecurity analyst would be doing in Elastic's security team. For example, we have sub-teams for detection, response, and threat intelligence. And things could be slightly different in your own organization, but the responsibilities will definitely overlap. You could be managing and creating detection rules, threat hunting, dealing with incident responses, or investigating cybersecurity literature in one of these teams. No matter what kind of cybersecurity analyst function you are in, or people in your organization are in, you could be looking through alerts, logs, rules, and I guess that's something we're pretty good at. It's a lot of information, though, lots of skimming, scrolling, and then in response to what fire hose of data you can parse, you can find out relevant ways to resolve or prevent malicious attacks. Speaking of data, you might know Elasticsearch, which is a platform and technology for quickly finding the right information from a lot of data in a lot of industry applications. And Elastic built the security solution precisely because we found that this search functionality is essential to cybersecurity, because it consists a lot of searching for malicious behavior from hundreds and thousands of logs and stopping them or preventing them. And Elastic is a search company, and security is a data problem. It's part of our 3 solutions here at Elastic, which are enterprise search, observability, and security. So you can see on the top row, those 3 first columns. And security is where the team I'm part of is located. And this doesn't mean at all that we're isolated from the other solutions, though. It's thanks to the logging from our observability solution and the search capabilities from the search solution that powers the data that's needed for security responses. And of course, in turn, providing the data that's needed to train machine learning models. Yeah, so we are here. And as you can guess, we also use the Elasticsearch solution here at Elastic. And previously, I mentioned that a security team might be responsible for maintaining and creating detection rules. Here we have thousands of rules that have been added over time. For example, detecting suspicious child processes, malware file uploading, lateral movement, etc. So I guess just to elaborate for those in the audience that might not work with rules per se, it's kind of like a, if this happens, then generate an alert, right? So the rule could be, oh, if we detect this unusual process execution path, then we'll have an alert in the logging. And this is pretty common practice in cybersecurity alerting. And no matter what kind of security platform you or your organization is using, there's a large amount of domain knowledge that's required. And that's what folks in security are good at, taking this domain knowledge and using it to identify and solve these issues, right? So for example, here is an example of a detection rule that notifies that a Java process is using a particular port that's unusual in this specific environment, and then creates an alert. But it's really hard to use our domain knowledge to solve the most important alerts if there's just too many of them to maintain or to add new rules in a timely manner. Especially in a very large company, there's so many combinations of logs, so many combinations of users and hosts every day. So we wanted to detect a suspicious behavior with manually defined rules. It might look like this. For example, like, oh, if there's a process where the parent process name is in one of these, and then also the process name is in one of these. And in the example, there's only 4 in the list, right? But it could be actually hundreds of thousands of combinations. And then when you extend that to all the scenarios, it could be millions and trillions of combinations. And there's drawbacks of using manual heuristics in these lists completely to not being able to generalize to new attacks that often. And it also requires manual effort and customer environment facing tuning, right? So each company, it might look different. So often we do run into questions that are too complex for heuristic-based detection rules. So let's say we wanted to distinguish, how do we actually distinguish this particular behavior from other similar benign activity, right? It's something that security teams need to address in order to be nimble and fast, and that's where machine learning can help out. So that brings us to the next step, so helping you understand how machine learning works behind the scenes and examples of how we use it in Elasticsearch. I'll just jump right into it with the first machine learning model example. Tree-based machine learning algorithms are pretty commonly used family of algorithms here. And I promise this example is not going to be scary. So let's look at this slide here. Let's say you're sitting on your couch and you're remembering that you don't have milk in the fridge, right? That's something I think a lot of us that happens to a lot of us. The store is a 10-minute walk away. You could quickly go and buy milk, but should you walk to the store? Based on many past examples of going outside, right, you might, as a person, learn that if it's sunny and the humidity is normal, then you can walk to the store. But if it's raining and it's really windy, don't walk, right? So no, but instead you could drive or go another day. You need a sufficient amount of past experiences, right, for the results of the decisions. In order to be able to determine, like, okay, in this scenario, I do this. In this scenario, I do not do this, right? And for humans, we might have 100, thousands, maybe thousands, that's most of examples for this, right? But the idea is that, like, with thousands or even more, hundreds of thousands, a machine learning algorithm can just learn from this data in a mathematical way, right? Given this scenario isn't malware, given this scenario is not malware, right? It can be applied to that as well. And of course, like, I'll be using this store example a little bit just to tie it back. Here's one example of how we use a tree-based model. A living off the land attack is when an attacker uses a existing benign process to execute something malicious. So for example, using a Windows pre-installed program to execute some malicious scripts in order to reduce detection. And as part of our Elastic Stack telemetry, users have logs that they can see of the hosts and users on their network. The logs might have the information we see on the left side of the slide. So it's like, quite a lot of information in this object, this log. And as part of the machine learning training, it's pretty important to do data cleaning to extract the features for machine learning. In the grocery example, the features for ML is like, oh, is it sunny or not? Is it windy or not? And here is like, what's the process name and what's the process parent name, for example. And then I'd like to shout out my colleague Apurva Joshi, who worked on this project. And next, we can use these features with the tree-based model to determine if an action was a living off the land attack. So that's one example of a tree-based model that we're using here. And the second one is for domain generation algorithms, DGA. It's a technique employed by malware to ensure that the infection of a client machine evades defensive measures. So oftentimes they might use a DGA technique, might use an infected client machine to communicate with the command and control server. So somewhere that they can access more information and kind of do more malicious behavior. But they want to hide the communication by using hundreds or thousands of randomly generated domain names, which ultimately resolves to the IP address. And since hundreds and thousands of domains could be randomly generated, this is also a case where sometimes heuristics can be hard to stop these attacks, right? Because you might have a list and that's like on just like hundreds and thousands of domains that might not cover every case in a manual scenario. So we use a boosted tree classifier. So it's like another type of tree model with the features such as domain, subdomain, registered domain, etc. And we use this to predict the likelihood that a domain is malicious or benign, and if it's used to like do a DGA attack. And we do have more in development, such as data exfiltration, which my colleague Omid is working on, lateral movement, which my colleague Kirti is working on, and we have many other cases of detecting suspicious user behavior or using session analytics to identify what kind of patterns that a user's behavior is normal or not normal, and that's ongoing. We'll probably have more in future presentations. Yeah, so next I'll introduce another machine learning example that we use often in security machine learning. We have hundreds and thousands of millions of types of logs and information in the logs and possible combinations of actions, as I've mentioned before. So let's take this graph, for example. If there's a scenario where there's two attributes of a behavior, so let's say like the process name is X1 on the horizontal axis, and then like on the vertical axis, we could have like a duration of the process, right? So there could be, if it's plotted out, then there's going to be a cluster of like normal behavior, like let's say the blue one, a cluster that's like also normal, like the green one, and then some abnormal behavior that could be identified, which they're not similar, right? If they're not the same as the blue cluster and the green cluster, that means they're just different. They're anomalous behavior and they could be malicious. So if we think about this as there's two axes on this graph, right? So it could be the process name and it could be like the duration that the process has been running for. But then there's much more we know about the process, each process and each log, right? They could have 10 features, like 100 features, and then that would be like a multi-dimensional space. And if you plot it out on a multi-dimensional space, then you could still see which ones are the anomalies because they don't fall into other normal behaviors. And this is commonly used in cybersecurity. This is called anomaly detection, but it's also commonly used in finance, right, to detect suspicious transactions or logins or fraud detection to see what kind of transaction is fraud and what kind of transaction in finance is normal or not. So this is very common because it works. It can focus on dealing with a huge scale of data that would make a human team really fatigued if they had to go through every single type of log and every single combination of behavior to determine what's not normal. And compared to using the rules to try to capture everything and maintain all the rules for all known scenarios, we want to help build on top of the rules, right? This is not meant to replace rules by any means, but it's meant to deal with the sort of problem, the sort of question where it's really hard to account for all sorts of scenarios. So machine learning can find patterns in the large amount of data to identify outlier behaviors. And for example, in Elasticsearch and users of Elasticsearch, there's around 50 to 60, probably even more in the future, pre-built anomaly machine learning jobs. So I think here they can detect like a rare hour for a user login, or if a user is trying to log in like a strangely large amount of times, that could be an anomaly. So there's more at the URL, the website that's linked there, and you could find some other types of pre-built machine learning jobs to detect these anomalies. So now I'll just show a quick example. So it's kind of like the machine learning jobs can generate some alerts based on anomalous behavior. Yeah, so we have like a typical Elasticsearch log interface, and then it'll show some logs. And then the machine learning job that's installed on the Elastic Stack could generate alerts that says, oh, this is unusual port activity. And this could be the same with the other examples that I've shown as well, like the strange login times, et cetera, et cetera. Okay, so now we're in the last section of what machine learning enables us to do. And like I said before, machine learning is not really meant to replace all the rules that I mentioned before. It's meant to help us focus on what we're best at doing, right? I mentioned that all the teams here in security, we have a vast amount of domain knowledge, and each team has a different type of domain knowledge. But if there's like an overabundance of logs or scenarios or just like combinations of possible behavior, it's really impossible for us to manually go through all of that. And then if we're manually going through all of those things, that means we're not using our domain knowledge in the places that matter the most. So I think it helps us focus. It helps enhance what we do. And as Samantha Zeitlin says, she's the senior manager in my team, machine learning is like a more sophisticated version of automating the boring parts, right? So the boring parts are automated, then we can do what we are doing best as humans. And of course, like I mentioned, it works in tandem with rules, and Elasticsearch has a very open culture, and we published a lot of our findings. We published a lot of our cybersecurity research and artifacts and things like that. So we can actually have the open source code of the or what I mean is that it's like publicly published on GitHub. So you can find some of these detection rules that we use too. And this is in order for other folks who work with rules or machine learning to be able to build on top of that. Yeah, so you can also find the anomaly detection on machine learning with machine learning in the Elasticsearch website here on this URL I've linked. And those are the steps. There are steps to do the stuff that I've mentioned before. The 50 to 60-ish jobs that you can install. Yeah, and so I'd like to thank my team, which is the Applied Machine Learning and MLOps team combined within the Security Machine Learning team here. So I have myself, Kirti, Apurva, Omi, Jess, Ashton, Claudia, and Sam. Yeah, so open to any questions and feel free to learn more about what we have here on Elasticsearch and machine learning.
Great presentation and information, Susan. Does anyone have any questions for Susan about applied ML and with cybersecurity on how we use machine learning with cybersecurity? I believe what you did, Susan, what you demonstrated was very detailed and showed not only what machine learning is, but how we apply that model with Elasticsearch in our product, and then using that example as far as with the tree, going to this grocery store, going to the store, pick up milk. I did like that. Does anyone in the audience have any questions? Okay, if there are no questions, if there's no, I see one. Great presentation. So great feedback. So great presentation. Okay, if there's no more questions or anything like that, then we're going to go ahead and conclude this session, and thank you everyone for joining, and then thank you everyone that will watch the recording as well. And excellent job, great and excellent job, Susan, and thank you for presenting today. With that, goodbye everyone, and have a wonderful day.
All right, thank you.